There's just another couple of points that I want to talk about before I go on to an example, and that is, you can see here, back to my first situation, we would call this situation approximating the area using the trapezoidal rule and two applications of the trapezoidal rule. Now, I think that's doesn't require any explanation. However, the thing I'd like to point out is that in two applications, we require three function values. Now, you'll always have at least two function values, the first one and the last one, but with two applications, we have to introduce another function value, which gives us three function values. What happened in this case, where we now have three applications? How many function values did we end up? Well, obviously the first and the last, which is 2, and another 2, which is 4 function values. And then in the third situation, we had 1, 2, 3, 4 applications, and 1, 2, 3, 4, 5 function values. So you'll know that if you're asked for n applications, then you will need n plus 1 actual function values. You'll hear from tutors and in other various places often that they encourage you to put information into a table. I strongly discourage that. I believe it reflects a lack of understanding of what really is going on, and ultimately the very best way to do maths is you're doing it because you understand what you're doing. Let's have a look at this example, and even in this example you're going to see a slightly different way of talking about the number of applications. It says find an approximate for the area under the curve y equals x squared for values of x from 1 to 3 using 4 subintervals. I haven't talked to you about subintervals, so what's that? 4 subintervals. So let's make sure we're clear about what a subinterval is. So subinterval is like application. We're going to have 4 trapeziums. Now, with 4 subintervals or 4 trapeziums or 4 applications, we need 5 function values. You can see I've drawn here the curve y equals x squared and I've put our boundaries from 1 to 3. 4 subintervals. Now, if I put a line in here, I've got 2, so if I divide them up again, I've now got my 4 subintervals. That would give me this function value, 1, 2, 3, 4, 5 function values. Normally we've been calling this A and this B, and we've had H, abstract H. Hopefully you can see that, and you could write that A is 1, B is 3 if that helps. H I think we get from the diagram very, very easily, and I discourage you also from just going to a formula about H. Think about the diagram, use your diagram, and that's where curve sketching is so important. And from your diagram you'll be able to see, so H is the distance between these function values, and H is equal to 1/2 or 0.5. Now the pattern, fairly simply, was our H on 2, our first function value, so our function value when x is 1, and our function value when x is 3, and twice all other function values. So we'll need to know the function value at 1.5 and at 2 and at 2.5. So you can see now that I've put the actual values into that formula. We established that h was a half, function value at 1. Remember, this function is x squared. It'll be 1, and at 3 it'll be 9, and 2 times these values. And that simplifies then to give us 8.75 units squared. Interestingly, if we did it using calculus, we'd have the area is equal to the integral 1 to 3 of x squared, and add 1 to the index, divide by the new index. I just don't know why that's not scrolling. Hang on. Whoops. Subbing our 3 in, 1, and you get that the area is 8.6. Now, we could actually see that, so the real area was a little bit less than the area that we got from our trapezoidal rule. When your curve is concave up, you will always overestimate using the trapezoidal rule, and when your curve is concave down, you will always underestimate with your trapeziums. Just a little point of interest. Now, the presence of a table in this next example is not to be confused with the table that I said that you might be encouraged to put together from other tutors and you might see in other textbooks. This table is not to be confused with that. What this table is actually doing is actually giving you the function values. It's actually saying that the function value at when x is 5, that's right here, that the height of that is 10.2. So note that we don't even know in this question the actual name of this function. That's not given. It just says during the survey of a headland, the following offset measures were obtained by a surveyor using the trapezoidal rule to determine the approximate area. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10 sub-intervals, 10 applications. We've got, well, actually 1, 2, 3, 4, 5, 6, 7, 8, 9 values. Now with 10 applications, shouldn't we have 11 function values? Yes, we should. And I guess the little complication to this is that you're not told the function value at 0, but we'll just add it in here and say when x is 0, the offset was 0. And down here at this end, when x is 50, the distance also is 0. That then gives us our 11 values we need for 10 subintervals or 10 applications. I'll pause the video and write up the solution. So you can see I've written h on 2, f of 0, so this is like f of a and f of b, then 0 and 50, and I just wrote 2 times all the other function values. And provided I've done that correctly, put that into the calculator correctly, I come up with that answer. You could check that for me. Now, yeah, the reason I include this example is because like I said initially, we're not given the name of the function. We're actually not able to work out what the function of, we're not able to work out what the function values would be because we haven't got the function. Now, you'll see that this is a common style of question where you're actually given the function values in a table. And it is often this situation as well, or at least one of these ends is needs to be interpreted as a function value of 0, so keep that in mind. I think you'll be fine now to do the questions from the exercise. Well, just before you do, could I encourage you to jot down the key ideas about the trapezoidal rule? I'm sure there's many things that I have emphasised. If you maybe do a rewind of some of the videos and like I said, jot down the key ideas so that, yeah, you can talk to me about that at the beginning of the lesson.